The greenhouse effect. You hear that phrase all the time, right? And let's be honest, it's usually painted as the bad guy in our climate story. But is that the whole picture? Let's dig in and figure out what the greenhouse effect actually is.
So let me just ask you this straight up. When you hear greenhouse effect, your mind probably jumps to it being a problem we have to solve. But what if I told you that without it, none of us would even be here? That life on Earth as we know it just couldn't exist?
That's right. Before we get into any of the problems, we have to get this one thing straight. At its core, the greenhouse effect is a good thing. Actually, it's more than good. It's an absolutely vital, totally natural phenomenon.
So what is it exactly? Well, the easiest way to think about it is like a giant, invisible blanket for the planet. The sun's energy comes in and warms up the Earth. The Earth then sends some of that heat back out towards space. But, and this is the key part, certain gases in our atmosphere grab a portion of that outgoing heat, keeping it close. It works just like the glass in an actual greenhouse, you know? It keeps everything inside nice and warm.
And believe me, the difference this makes is just staggering. Without this natural blanket, Earth would literally be a frozen, lifeless rock floating in space. With it, we get the warm, thriving planet that we all call home. The secret, as we're about to see, is all about balance.
Okay, so if the atmosphere is our planetary blanket, what's it actually made of? Let's meet the gases that are doing all the work. These guys are officially known as greenhouse gases, or GHGs for short. They are the glass in our planetary greenhouse. They're the specific molecules that are really, really good at grabbing that heat and keeping our planet's temperature just right.
And here are the main players on the team. First, you've got carbon dioxide, CO2. This is the big one, mostly because there's just so much of it. Then we have methane, or CH4. Now this stuff is way more powerful at trapping heat than CO2, especially in the short term. Next up is nitrous oxide, N2O, which is not only powerful, but it sticks around in the atmosphere for a super long time. And finally, you've got fluorinated gases. These are man-made, and they are incredibly potent heat trappers.
So, we've got this natural, life-giving process and the gases that make it all happen, so where's the problem? Well, this is where our story takes a sharp turn. The issue is, we've started thickening the glass. See, the problem isn't the greenhouse effect itself. It's what scientists call the enhanced greenhouse effect. And that's the key word, enhanced. This is the unnatural speeding up of the process, and it's called by us pumping a massive, rapid amount of those GHGs into the atmosphere. We're essentially turning that perfect blanket into a heavy, suffocating duvet, and it's trapping way too much heat. And you can see this shift so clearly when you look at history. For thousands and thousands of years, the amount of these gases was pretty stable, and that kept the climate balanced. But then, around the 1800s, the Industrial Revolution kicks off. We start burning fossil fuels like there's no tomorrow, and that brings us to today, where those GHG levels are way higher than they should be, throwing that whole delicate balance out of whack.
So let's get real for a second. Where is this human fingerprint actually coming from? What are we all doing that's adding all these extra gases to our atmosphere?
Well, when you look at the data, the answer is pretty overwhelming. The single biggest piece of the pie is how we produce and use energy. You know, burning fossil fuels for electricity, for heat, for getting around. That's the big one, followed by industry and agriculture. And here's how that really breaks down in our daily lives. It's the power plants keeping our lights on, it's the fuel in our cars, our trucks, and our planes. It's making stuff like cement and steel, but it's also our food system. Livestock create methane, and fertilizers release nitrous oxide. Even things like cutting down forests, which removes trees that soak up CO2, and our trash breaking down in landfills. It all adds up. It's all woven into the fabric of our modern world.
So, let's just pull this all together. If you take away just one single thing from our chat today, please let it be this: the huge crucial difference between the two greenhouse effects.
On one side, you have the natural effect. Its cause is a natural atmospheric balance. Its job is to keep Earth warm and livable. And the result? A stable climate that supports life. But on the other side, you have the enhanced effect. Its cause is human activity. Its function is trapping excess heat. And the outcome is a rapidly warming planet and a seriously disrupted climate system. One is our planet's life support system. The other is the challenge of our time.
Which of course leaves us with a pretty big question. The science is crystal clear. The original greenhouse effect is not only natural, it's necessary. But we have cranked it up to a dangerous level. We've thickened the blanket. So the real question we have to ask ourselves now is, how do we get back to that balance?